thank you very much for joining us. You might have heard that there's this new technology called AI, and it's getting a little bit of buzz. But in all seriousness, AI is a incredibly nuanced conversation when it comes to the world of sustainability. On the one hand, it holds unbelievable promise in terms of the number of use cases that it can help. And one of the things that, as a reformed strategist for the last 3 years, that I look at and say AI can bridge the divide between what we often do is say, we think this is what the world looks like, and AI can be the bridge to saying this is what the world actually looks like. If you've ever heard the phrase, a map is not the territory, AI gets us closer to knowing exactly what the territory is, whether it's the ability to map every square meter of the Earth and monitor how it's changing, using combining AI with geospatial data, and looking at the myriad number of use cases, whether it's doing scenario planning on resiliency, helping fight wildfires, helping address different kinds of scenarios. But on the other hand, it does require a lot of energy in order to power AI. And one of the things that we're going to do on this panel is try to unpack the nuance of this complicated topic, but one that I feel very optimistic about when it comes to the role that AI can play in addressing this urgent crisis that we have called climate change. I'm going to pass it to my partner, Johannes, who is going to lead us through and introduce Bernhardt and then the rest of our panel to come. Thank you so much.
Thank you, Steve. Good afternoon, everybody, to this panel. My name is Johannes Truby, and I'm a partner at Deloitte, where I'm responsible for a service called Energy and Climate Economics. Now, to kick this off, as Steve has said, AI is really one of the defining megatrends of this century. And what that means is that as we use more and more AI, we need more and more computations, and these computations happen in data centers. And those data centers, for every computation they make, they use energy. And that, with the big wave of new data centers being constructed, has led to some strain on the power systems, especially locally. And this has also, and we've all heard it in the news, this has led to some concerns about this additional energy demand from data centers also leading to increasing emissions. And that's why this topic is so timely here at COP, where we're really looking at tackling emissions. And therefore, even though data centers are only responsible for 0.3% of the global CO2 emissions today, it's a very, very important topic to talk about. And in order to properly unpack AI and the energy use of AI, we have conducted a very detailed study that we're launching actually today, and you'll find a QR code of the study later on up on the screen, where we deploy science-based economic modeling and very heavy-duty data crunching to understand, to first take stock of the energy demand of data centers, but then also look ahead into the future and assess how data centers could drive energy demand. Today, data centers use around 340 terawatt hours of electricity. That's about the size of an economy like Saudi Arabia. And if we look out to 2030, it's totally conceivable that data center electricity demand could reach 1,000 terawatt hours. And I'm sure my colleague Thomas from the IEA would agree it's very similar to what the IEA has said. But if we look further out into the long term, we need to distinguish between three important uncertainties. The first uncertainty is the pace and scale of the AI uptake that essentially determines the number of computations that need to happen in data centers. The second uncertainty is the potential for efficiency gains. And that potential for efficiency gains will essentially determine how much electricity you need for one computation in a data center. And the third uncertainty, especially if we look out to 2050, is how this energy will be produced. Will it be renewable energy? Will it be clean energy? Will it be fossil energy? And that will determine the environmental footprint of the data centers. Now, our modeling suggests that if we take a scenario in which we see a continuation of current growth of AI uptake combined with current trends in energy efficiency improvement. We would see data center electricity demand to increase to around 2,000 terawatt hours by 2050. And just to put this in perspective, that would be around 3% of electricity demand by 2050. And what that means is that data center electricity demand will by far be outpaced by other electrification applications like e-mobility, like electric heating, or green hydrogen. If we look at another scenario where we look at the concerns that have been voiced around the continuous improvement of energy efficiency in data centers, then we would see electricity demand growing to around 3,500 terawatt hours. Again, to put this in perspective, that's a little less than the US consumes in terms of electricity today. Still, that would be less than 5% of overall electricity demand in a net zero scenario by 2050. And then on the other end of the range, a more downbeat perspective on the uptake of AI would lead to around 1,700 terawatt hours by 2050. So, what does this mean for us today? First and foremost, I think what we're observing with AI and data centers is very much a harbinger of what the world will experience once the electrification that essentially all net zero scenarios foresee kicks in. And as such, AI and data centers, they're really frontrunners. They're really frontrunners of the energy transition, and they're very, very good case studies on learning how to do things right once really the biggies like electric cars, like heat pumps, or electrolyzers come into play. And then it's also critical to understand what tech companies, what governments, but also what consultants like Deloitte can do to make sure that we continuously strive for the best available technologies in data centers. The next point is that we need to make sure that the electricity that data centers consume need to be clean. And here, this is a specific task for the electricity suppliers, for the utilities, but obviously also for the tech companies that use that electricity, a very critical point to get to an inflection point of emissions by the 2030s. And last but not least, AI shouldn't only be seen as a user of electricity. It certainly is a very important user of electricity, but AI technology also has the ability to significantly help us lower emissions in other sectors, for example, by making processes much, much more efficient. And with this, I'd like to pass the mic on to Bernhardt, who's going to introduce the panel.
Great. Thank you very much, Johannes. I'm really proud to moderate what is an incredible panel for such a subject. We have Sarah representing really data centers or cloud centers herself, David representing a supplier from E.ON who makes an effort to become the first green supplier in Europe, one of the biggest ones. We have Thomas from the International Energy Agency, but we have Josh from NVIDIA. And if you talk about AI and using that for good and the energy, of course, question behind it that Johannes pointed out, and also my dear friend Steve was already addressing in his remarks, we have to talk to NVIDIA, because NVIDIA is key to solve or not solve the big question that is behind the question, how can we solve this and what role does efficiency play here? So I would like to open the floor and ask Josh a little bit about what his take on this is, and which role particular he sees with regard to the efficiencies that we are seeing all over. And we all know that there are a couple of answers to the energy transformation. The first one is always efficiency. We have seen this in Germany after the energy crisis. There was an increase of efficiency of 15% that we have not seen before, but it was taken then because of the high energy prices, and that we hope that it will come through technology development a lot to reduce it to the numbers that Johannes was just referring to. So, Josh, over to you.
Thank you. I think my role on this panel might be the one to bring the hope that we're looking for and the optimism around climate. I know at COP, we can sometimes get frustrated about seeing our ambitions, lofty ambitions, and the difficulties we have in achieving them around emissions reductions and trying to mitigate climate change. And I think there is a lot of reason for us to be really optimistic, and more optimistic than we've ever been, despite those challenges, because specifically of AI. And I may sound like somebody who has been drinking the Kool-Aid at NVIDIA. I understand that, but my background's in engineering, and the data actually is supporting a very good, optimistic picture of how AI can actually help us with our climate change problems. Now, there are a few reasons that I think AI is really going to be transformative in climate change, but also in managing energy. So I think we've got a slide to pull up, if we could pull that up. First point I'll make, there's been a lot of talk about energy and AI and how AI is consuming energy, and Johannes and the Deloitte study are good at pointing out kind of what some of the forecasts are around that. There are a few reasons why the most stark and scary projections for energy consumption are overestimates. And one of those, you'll see on the screen behind me, is the platform on which AI is being built, called accelerated computing, is actually the most energy efficient platform that we've seen, both for AI, but also for a lot of other computing applications. And the chart on the right shows the trend in energy efficiency for accelerated computing over the last several years. And it's hard to see the slope down at the right-hand side of that chart. But what that shows is a 100,000 times reduction in energy consumption for the same type of AI inference. So the same workload, same AI workload, just back 10 years ago, took 100,000 times more energy. And just in the past 2 years, we've become 25 times more efficient for AI inference. That's a 96% reduction in energy for the same exact workload, computational workload. So as you see the growth of AI, and you see, oh my goodness, we're building more data centers, AI is consuming more energy. Yes, that's true. And we do need to manage near term the mismatch between supply and demand for energy, which came about because AI really burst onto the scene in something of a surprise. So there's a short-term mismatch. So we do need to wrestle with that. And I don't want to sugarcoat that challenge we have in the near term. But the trend towards increasing energy efficiency in accelerated computing and AI is consistent, and it's dramatic. So in another 2 years, we may see another 96% reduction in energy consumption for the same AI workload. It's a really strong countervailing variable as you're thinking about AI and energy consumption. The second point I'll make on AI is, and accelerated computing more broadly, is substitution effects. So you've got a lot of existing infrastructure with data centers, and that infrastructure it's now becoming old technology, which is much less efficient than accelerated computing for most workloads. We estimate that it's about 10 times, and this is what the data shows, 10 times more efficient to run many workloads on these accelerated computing platforms than it is on traditional data center platforms. So there's a huge opportunity for us to actually reduce the energy consumed in existing data center infrastructure if we use this new platform. So that's on the energy consumption side. And I think, as Bernhardt mentioned, and Johannes mentioned, there's a lot of reason to be optimistic as well about how AI is going to help us across sustainability. We're at COP, we're talking a lot about environmental issues, but we also talk about the social aspect of sustainability. The democratization of technology and intelligence and information through AI has the potential to have really profound impacts for good, for economic development, and on human rights and so forth, especially in the global south. This could be a step change for us once we figure out how to implement it on the social side. On the environmental side, however, it's even easier to see near term the impacts. And one of those is energy efficiency. So Johannes mentioned, data centers. And the IEA estimated in their last study that data centers account for maybe 2 or 3% of total energy consumption. And AI is currently a small fraction of that. But AI has a potential to make other sectors much more energy efficient. So if you look at manufacturing, we're seeing around 30% reductions sometimes in energy requirements if you use AI to help optimize the manufacturing process through digital twins. So huge potential on that big chunk of the of energy consumption that isn't data centers to help reduce energy consumption and also help with resource conservation as well. So huge opportunities to be optimistic. I'm sincerely optimistic about AI and its potential for sustainability.
Thank you very much, Josh, not only for your optimism that I really like, but also for broadening the discussion a little bit. It has aspects of just transition. You just said this. We discussed the digital divide the whole day. Actually, this is the first time that at COP, I'm a COP veteran, I've been at 20 COPs, the first time that we have a digital day or technology day at any COP. So it's really an innovation in itself, and it's really important that we think about how the question of bridging the digital gap and all these questions coming along with it. But now we're discussing really the energy question and AI, and you referred to a couple of numbers. I like the chart, and I like particularly that you said we possibly have another 96% of efficiency wins in the next 2 years. Sarah, on the ground, in your cloud centers, how does this impact your work and how you deal with this?
Hi there, Sarah Axelrod with Crusoe. And I'm going to echo Josh's note on optimism. So Crusoe is a vertically integrated AI infrastructure company. And what that means is we operate sort of at all levels of the stack. We have a commercially available AI cloud product that's out in the market today. We build our own data centers that, from the ground up, mostly greenfield sites that are very AI workload focused. And then I think this is the thing that makes Crusoe really unique is we locate those data centers at the site of clean, low-cost, abundant energy. And this is really a change from the model of how traditional data centers have been built, which is data centers in corridors that are very data intensive, very energy intensive, and you build a data center, you connect it to the grid, and off you go. You run computing platforms. What's really interesting about AI workloads is they are more latency tolerant, which means, and this has been Crusoe's model from the very beginning, we're about 7 years old, is we bring the computation to where the energy is, as opposed to bringing energy to where the data centers are. So what that looks like in actuality is we have data centers out in the middle of nowhere. We have data centers behind the meter wind farms in West Texas. And I think a great example here is, for those of you not from the United States, West Texas there's a lot of wind, there's a lot of solar, there's not a lot of people, and there's not a lot of transmission infrastructure. So in West Texas, for example, the wind blows, and they have to curtail that energy about 20% of the time because it has nowhere to go. So instead of that energy being wasted, we can put a data center out in West Texas, soak up that excess energy that never would have made it to the grid, and all of a sudden you're doing two things, right? You're incentivizing the build out of new renewable energy. You're taking a very energy-intensive workload off the grid, so you're stabilizing the grid and not putting that additional strain onto the grid. And and the other thing is and it gives you more flexibility. So I think with this model, this vertical integration of Crusoe, what we're seeing is a couple of things. The first is we're proving this model that you can in fact go to where the energy is, and I have to give my energy team a lot of credit for being incredibly creative about how we do this. Pick your energy solution. And I think the other thing is now we've ended up with a customer base with our cloud product and with partners like NVIDIA who, as we start to see, and I think to Josh's point around there's so much good that AI can do, particularly in combating the climate crisis, it's those type of customers who are also really concerned about their carbon footprint. And and I think the last thing I will say is, back to this point of sort of building this infrastructure from the ground up, NVIDIA is doing fantastic work on, creating energy efficiency in their chips. The data centers also need to match that, right? We need to do our best to provide infrastructure to say, okay, not only how are we thinking about networking, how are we thinking about cooling, how are we thinking about energy efficiency sort of in the four walls of this data center to then say, maximizing the energy efficiency potential of the chips themselves. So, this truly is, I think, a partnership and a really interesting time, again, to build this from the ground up with an energy-first approach.
Thanks, super interesting insights. Now let's go to the supply side. David, I mean, E.ON has incredible ambitious goals with regard to their decarbonization, and you are confronted with your customers who buy. How do you take it?
Yeah, thank you for having me. It's E.ON being the largest grid operator in Europe, and we serve roughly 50 million customers across Europe. And so we look at AI and data centers from three angles. One is it helps us to manage this ever complex system. And let me put that in numbers. We have a couple of years ago, we've connected 1 million assets of renewable feed-in for the first time. Today, we are connecting, or last year we connected 250,000 in 1 year. This year it's 500,000, and it will be 8 million in 2030. That means we're connecting one new renewable asset every 8 seconds. Too much to handle for humans. So AI really helps us to manage that complex system. And number two is then we look at data centers as, let's call it electric fans, electric heaters that can also handle data. I mean, data centers will be able to provide roughly 20% of all district heating demand in Germany in 2030. And then, of course, we are the grid operator that has to connect the data centers. And with energy utilities is such a thing. In the past, you would look at them a bit like you look at the white guys in basketball. They're big, but slow. You know? And so now we have to really, it takes 2 to 4 years to build a data center. It takes up to 3 times as long to actually build the grid connection. In Frankfurt, in Germany, we are booked out of capacities to connect any new data centers for the next 10 years. And that's the challenge we're having. Connecting the data centers, utilizing AI to manage that complex system, and really then on energy efficiency using that excess heat. And let me just give you one example of how we actually use AI. I mean, on that slowness, we had in the past in Sweden, when somebody wanted to connect a renewable asset, it was you send a letter, you get a questionnaire, and then after 20 days you get approval to connect it. And we have digitized and automized that process from 20 days down to 19 minutes. And that's the level of speed that we need to accelerate it. That's Sweden, that's right.
Yeah, that's super interesting. I mean, acceleration of permitting processes is one thing that I use always as an example how we can use AI, and I know that many public sector clients of us are working with this, and colleagues of mine. Speaking about public policy, coming about to the policy side of this, International Energy Agency did already publish something and is working on this, and we are closely connected on exchanging our numbers. What's your take on the policy side? What can we expect and what can we see already on the policy side, both on strengthening and also getting a kind of regulation in this space of energy and AI?
Yeah, thanks very much for the invitation, and congratulations to Deloitte for a really great study. I read it yesterday and I think it's fantastic. So well done for that. I wanted to just start building off what Josh said with a little calculation that we did at the IEA. And it's not copyright, you're free to use it as you travel around the world, Josh. We calculated that training ChatGPT 10 years ago with the hardware available 10 years ago would have used about the same electricity consumption as the entire consumption of China. Okay? So we really need to understand what the efficiencies have done for us in enabling the AI revolution and where this is going. So I just wanted to make 3 quick points from the IEA's perspective. The first is regarding electricity consumption of data centers today and why this is a tough but manageable issue. So today, data centers are about 1% of global electricity demand, but there are 2 characteristics of data centers which makes it a particular public policy challenge. The first is that they are spatially concentrated. So a big data center can be about 100 megawatt, for example. That's about the size of a large steel plant that uses electricity. But data centers are about 3 times more spatially concentrated than steel plants. We did a geospatial analysis looking at all the steel plants in the US and how spatially concentrated they were. and all the data centers in the US. And data centers are about 3 times more spatially concentrated. So that creates a lot of pressure on electricity grids, on the generation capacity in the locations where they are concentrated. So the more we can do to decrease that spatial concentration, the better it will be for our systems. And the second characteristic of data centers is speed. They're coming up so quickly that they're overwhelming our policy processes in terms of grid connections, in terms of approval processes, and so on. So this is creating a really big challenge. The second point I wanted to look at was, where do we at the IEA see electricity demand from data centers going in the future? And I think our vision very much aligns with the projections made by Deloitte. Data center electricity consumption will grow substantially, but it will not be the most important driver of electricity growth in the future. So just to give you a sense, in our estimate, data centers today are about 280 terawatt hours of electricity. Suppose you double or triple that by 2030. That's a substantial amount of electricity, no doubt about that. China last year increased its electricity demand by 500 terawatt hours, and will do so again this year. So just putting this in perspective, one data center in terms of annual consumption, again, this is a big one, a hyperscaler, is about equivalent to the electricity consumption of 350,000 electric cars. This year, we're on track to sell globally about 17 million electric cars. So again, we need to put this in perspective. There are, however, some big challenges when it comes to projecting electricity demand from data centers. And that is, to put it bluntly, we as energy analysts don't really understand the sector. We don't have the data to understand the sector, and we need to talk to people like NVIDIA, like Crusoe, to better understand the operational characteristics of data centers. This is a really big gap. The way that I explain it, the metaphor that I use is, our understanding of the data center sector today is equivalent to if we were trying to project the electricity production of a country, but we had no idea about its installed generation capacity, only the vaguest understanding of the technology mix and how they operate. We're in the same position for data centers. So we need to get better as an energy community at understanding the data center sector, and exchanges with people like NVIDIA, with Crusoe, are critical for that. Last point that I wanted to make is on the benefits of AI. I worry that we're going to be a little bit like the proverbial fish. The fish doesn't notice the water that it swims in, right? And so we're going to start adopting AI in the energy sector. It's going to improve a lot of processes, but we're going to lack a bit of an aggregate perspective, an overview of what are the benefits that AI is providing and can provide in the future. So I think we as energy analysts, we need to get better at being more concrete about use cases and the potential benefits. At the IEA, we built a model together with MIT, trying to estimate from geospatial data what buildings at a building level in sub-Saharan Africa were connected to the electricity grid and which were not. And so from that, you could derive a more cost-effective and rapid electrification program for utilities, because you have a very detailed geospatial understanding of which buildings are connected to the grid and which are not, just from this model. So my final point is, let's not be like the fish which doesn't notice the water it's swimming in. Let's get a better understanding of the benefits that it can bring.
Thank you very much. All 4 inputs were really great and gave us a good overview about the discussion. I particularly like the kind of convergence that we've seen between the energy sector and the digital sector, that we certainly need to solve the challenge, not to say problem. However, we have a lot of coverage, media-wise, still on this issue, right? I mean, the Wall Street Journal the other day, before you came out with your first numbers, before we come out today with our numbers, predicted some 20-30% of energy use in the future will be used by AI. And I come from a part of the world we are well known for being the Silicon Valley of regulation, right? We're really good in this. And so I'm really a little bit not afraid, but aware that we might see more of those coming into this space. And so it's really important that we have this discussion and we have this convergence between sectors and are solution-oriented and very optimistic about it.
Johannes, thank you and Bernhardt very much for hosting this panel, and thank you very much for our panelists for answering the questions. A big round of applause, please, for our panelists. And my name is Vijay Sharma, and I lead the commercialization of our services for sustainability at Deloitte. As opposed to closing myself, I thought I would ask AI to close this session and read out what the algorithm heard from this panel and what it's going to say from a closing perspective. So let me just do that. Ladies and gentlemen, as we stand on the precipice of an AI revolution, it is imperative we address the environmental implications alongside the undeniable benefits. AI, with its potential to revolutionize industries and solve complex problems, comes with a significant carbon footprint. The energy-intensive process of training and running AI models, coupled with an ever-increasing demand for data storage, contributes to greenhouse gas emissions and electronic waste. The key lies in responsible development and deployment. We must prioritize energy-efficient algorithms, invest in renewable energy sources for AI infrastructure, and establish ethical guidelines to ensure AI is used for good. The future of AI is intertwined with the health of our planet. By making informed choices and fostering innovation that balances technological advancement with environmental responsibility, we can harness the power of AI to create a sustainable future for generations to come. So that's straight from the mouth of AI. On itself, it's very optimistic, so that's positive. By the way, that query took 2 watt-hours and 2 bottles of recycled water to generate for this. So thank you, everybody, and thank you for the panelists and Johannes. And please do go and read Deloitte's groundbreaking research led by Johannes and the team. It is extraordinarily informative. Thank you again.